In this video, we're going to talk about wheel fasteners. We'll talk about lug nuts, we'll talk about some of the tools and equipment to safely remove the wheel assembly and put it back on, as well as doing a final torque. So I've got here a bunch of different tools that we might use for taking wheels and tires off and putting them back on to a vehicle. And while it might seem like a pretty simple process, this is something that has a lot of best practices and nuance to it that we really need to pay attention to. It's a very high priority fastener on a car. We want to make sure that the wheel and tire assembly stays on the vehicle. You could imagine if a wheel and tire were to come off because it was loose or we damaged one of these fasteners, it could really create some big safety issues. So here on the bench, I've got a handful of things. First up, I've got this air impact. So this is a pneumatic impact, utilizes shop air or pressurized air in the port down here. And so we've got an air hose that will plug into the wall where our compressed air is. This has got a quick release collet on it that I've got to pull down. I've got to pull that down, push this on, and then let go in order to lock it in place. The upside and great functionality of an air impact gun like this is its strength. It utilizes small blows of really high torque output in order to loosen fasteners that might be 100 foot-pounds, 200, 300 foot-pounds. Many of these can go as high as 600 and 700 foot-pounds in their ability to loosen a fastener. So this is a great quick way to take the lug nuts off a vehicle because they are quite tight. Most lug nut specs and fasteners are somewhere between 70 foot-pounds to maybe 120 foot-pounds on a standard vehicle. This impact gun's got a couple features I need to pay attention to. I've got my trigger, turn it on and off. I've got a valve right here that slides back and forth for my direction, so I make sure I'm taking it off versus putting it back on. And then I've got a dial that can change the intensity of the output, and so I could adjust that maybe as I see fit. The last thing to note is that these guns come in a variety of sizes, and they're notated by the drive size for the sockets. This happens to be a 1/2-inch drive, and so I've got sockets that are 1/2-inch drive to match that. Sometimes you'll see that these will get stuck or maybe be very loose on specific guns. There should be a C-clip at the end of this. Sometimes that can get damaged with use, and so if you're having a hard time putting a socket on, we may need to inspect that C-clip, or we may need to inspect the end of our socket. Sometimes that will become burred, and those burrs will catch. Another important note with this air impact is that I always want to use a impact rated socket whenever I go to use this. An impact rated socket is generally a raw machine finish like this. It is made of a very high strength alloy steel typically. If you compare that to my standard chrome socket, these have been heat treated to a point for extra hardness. That helps with some strength, but it also makes the metal more brittle. And so these impact sockets are actually designed to deflect a little bit of the impact and blow of the impact gun's torque so that the socket itself doesn't fracture. So we're here at the Eclipse and we're going to talk about taking these lug nuts off to get this wheel off the car. I've got my air impact, I've got it hooked up to shop air. You can see that it works. And I've got a few sockets to show you and talk about. I'm going to stick to these types of sockets. These are a raw metal finish. The difference between this and the chrome socket is that it is a softer material. That softer material is able to take some of the blows of the impact and deflect it into the fastener rather than having it alter and destroy the socket itself. And so I've got some options along just picking impact sockets. I could use a short socket or a deep socket. What should I do? First, I should pay attention to the diameter, right? So this is a 21 millimeter. I always want to go and I want to check it on the lug nut, make sure that it fits well. I do have some choices about whether I use the short or the deep. And so we can take a look at this and think about where we're at. The short socket typically gets very close to the wheel face. You can see how close this is to the finish of the wheel, whereas the deep gives me a lot more space out this direction. When I'm using my air impact gun and I attach this here, with this kind of scenario, I typically don't have a big preference. And so it is really up to you in terms of what type of socket you use. At the end, when we go to torquing the wheel and we're putting our torque wrench on, then I think it's a really clear decision about which one is best or which one that I should use, because I really limit myself and open myself up to maybe hurting my knuckles, hurting my hand, or damaging the surface, painted and coated surface of the wheel by using a short socket like this. My personal preference is to use a deep socket like this. Even with the impact, I like the extra space that I'm able to hold on to the socket with here, so that as I undo the socket, I can kind of stop or control the tool better so that I'm not wiggling side to side where I might hurt the face of the wheel. This Eclipse is a good example. It's got really nice 18-inch machined and painted and coated wheels, and you can see where some of that learning has taken place. We have hit the coated surface with our socket. This often happens at our last lug nut we'll talk about, but we really want to avoid that, make sure that we're not leaving any marks or scuffs on customers' property. All right, so I've made my selection of a deep impact socket, 21 millimeter. Again, check that fit. It will feel a little loose. Impact sockets typically, as they wear, will have additional clearance within that, but I do want to check and make sure I have a good fit. Install it on my impact gun. I'm going to make sure that the direction of my gun is for loosening fasteners. On these particular impact guns, I need to make sure that this valve that's here in the center is pushed back, really to remove a fastener or take it off. And so I'm going to do that, put it up against, make sure I'm supported and straight so that I'm away from hitting the edges of the wheel. I'm going to run it out, and I'm going to take caution as I come out at the end here to make sure I don't drop this onto the wheel or miss and hit the wheel with my socket. I'm going to take that off. I'm going to find a place to put these to keep good track of them. I'm going to pick the lift arm over here. I can keep them really nice and set and be able to keep an eye on that I've got 5 as I go back together. The sequence that I go in as I take these off is not necessarily important. There is a critical piece as we go back together that we'll talk about sequencing. I've taken 4 off. This particular car has got 5 lug nuts. It's a 5-lug wheel hub. I want to be cautious about this last one. The last one that I take off, generally the weight of the wheel will begin to sag and it will tip. When that tip happens, if my socket is still here on the wheel will tip, and that's where we get the scratches that we talked about. You can also see it on my impact gun here, that I've got a lot of marks from wheels. And so as I do this last one, I got to pay attention, take a hand or something. I'm supporting that wheel so that when I let go, you see how much it moves. With all my lug nuts off, I can remove the wheel from the car now. A couple of notes that I want to pay attention to. One, anytime I have lug nuts, I'm probably in good shape that this wheel will hang on the studs and not fall down. But it is something I want to pay attention to. There's a lot of European vehicles out there that utilize wheel bolts rather than nuts. And those I've got to be really critical. I've got to think and keep my hand here, because once all those bolts are out, it will fall if it comes off just the hub surface or hub ring. I'm going to remove it very carefully. I always want to be careful that I'm not hitting the brake dust shield, the caliper, or any of those with the inner barrel of the wheel. Let's talk about some of the components and pieces now that I've got the wheel off. I've got my wheel stud. These studs are built in a variety of diameters and sizes. It really depends on the weight rating of the car. These are relatively small, probably a 12 millimeter, and there's some standard pitch, maybe 1.5 millimeters per one of these threads. When that stud's off, it looks more like this. On the back there where it enters the hub surface, there's a serrated piece and then there's a flange head. These get pressed into the wheel hub, and we rely on these serrations to hold that stud in place. This is a good thing to think about and have an awareness of, because if I exhibit too much torque on these, I can in some cases strip this, or if I was to break one of these off because I cross thread it and I continue to drive it home, it becomes a bit of a challenge to get these out. Take some extra work because I've got to take this all apart and push it out the other side of the wheel hub. There are 2 things I want to pay attention to as I have my wheel off, really with any service. One of them is the condition of the wheel studs. If I had any resistance as I removed lug nuts, I want to take a close look and pay attention to, are any of the threads damaged on these wheel studs. I also, as I go through service, want to be careful that I don't do anything to pry against these. I don't want to put a pry bar through my wheel studs and leave indentations that will cause issues with the lug nut going back on. The second thing I want to look for is, how does this hat surface and the center hub surface look? Is it clean? Is it free of debris, corrosion? If there is corrosion on these surfaces, I want to take some time to clean those up before I put it back together. If I determine that my hub surface has got a good clean surface, I also want to pay attention to the other side of things, which is my wheel. The hub flange area of this wheel can also be prone to corrosion, especially when we put aluminum wheels with a steel hub. There's a chemical reaction that takes place there, and corrosion is likely to form. When I get corrosion built up here, I can introduce runout, which is where this wheel, instead of spinning straight, basically will wobble because it's not flat against the hub surface. That creates tire vibrations, shimmies, and vibrations at highway speeds, and those are things that a customer is going to notice. So we'll take extra care and make sure this is clean. This particular wheel looks pretty clean. There's not really any buildup. We've got a couple options if we did find some buildup on that. One of those is to use a specialty tool like this. This is a 3M Rolock disc that is made for cleaning hub surfaces, so specifically on the car. It's got a center hole so that I can go over wheel studs and really get it cleaned up well. Typically I would attach that to a drill or some kind of pneumatic tool like this. If I don't have one of those, my other option is probably pretty readily available in any shop, and that's an angle grinder with some kind of abrasive disc. I do want to be careful about which disc I choose. The surface prep discs like this red or brown model are great for things like this because they don't remove material very fast. An aluminum wheel like this, it would be a really bad idea for me to take a sandpaper abrasive disc like this to it, because I'm likely to remove enough material that I could create a vibration and a runout issue by my own doing. And then I've basically damaged that whole wheel and it would have to be replaced. So my best option is one of the surface prep discs like this one. It kind of looks like a Scotch-Brite pad, or I can get into some of the softer plastic type discs, but again, with aluminum, I need to be really careful that I'm not going to remove too much material. Another topic to pay attention to, which doesn't come into play every day, but I want to have an awareness of the different types of lug nuts and how they seal against the wheel. This is a critical piece in getting the wheel centered so that we don't create runout issues and vibrations. I've got two very common types of lug nuts here. One of them is a shank style, which came off of this Eclipse. And so it uses a shank that's been machined with a fairly tight tolerance to the wheel. The wheel just has a flat surface, and the bore where this lug nut will go through, it relies on this washer to keep a nice contact and then gets threaded down. The alternative, which maybe is a bit more common, is just a taper or conical style lug nut where the actual holding surface between this and the wheel is established by this taper. And so the important thing with this is that I pay attention to how these wear over time. With a lot of repeat service, these lug nuts can develop a groove where they sit, and then the lug nuts may hold differently or center differently as they go on. That's a wear item I should pay attention to. Back at the car, there's one more thing that I want to touch on that has some great importance, and that's when I take this wheel and tire assembly off to do some kind of service, where do I keep it? Where do I store it? A lot of technicians will take these, roll them over, and maybe lean them against their lift. Depending on the style of the lift, it's pretty easy to store even all four wheels and tires this way, and it does keep them out of the way. But we want to pay attention to and have good practices. This does create an opportunity for me to forget that they're there, or for another technician to not know they're there. And say we lower this lift, I could damage the wheel and tire, potentially damage the lift. And so I want to be cautious about my choices there. Another one's just to lay it underneath the car, like that. I could do that. Again, I got to be cautious about the vehicle coming down. I got to be cautious about the type of service that I'm doing. I don't want any fluids to drip or leak on this and hurt the wheel finish or the tire. The last thing I want to point out is that because I would say a large percentage of cars that we work on and trucks that we work on today have some sort of coated and nice wheel surface. You know, it's painted, it's chrome, it's polished. I do not want to take this wheel and ever lay it face down because I create an opportunity for a rock or some abrasive on the floor, a tool, whatever the case, to catch this and scratch this. So now we'll put the wheel back on. I'm going to get a good handle on it from the sides, make sure I'm lifting with my legs. And I got to really watch for lining up my lug nut to have it come through and have the wheel set on. As I go through that process, I'm being very careful not to touch the wheel to the brake components or the suspension as best I can. Next, I'm coming back to my lift arm where I put my lug nuts. I'm going to start to pull those off and get those started by hand. I'm always going to take these lug nuts and start them by hand. I do not want to load them in my impact and just begin driving them on. That creates a risk that I'm going to cross thread something. A great tip that I can do is take my socket, load my lug nut in, and use that as a driver so that I can really get this started by hand. You'll notice sometimes this will happen that I can't run this all the way down because this wheel is pitched, and so I'm going to have to apply some force and run this down to hold the wheel flat. There is an upside to doing that in that it might save me a little bit of time as I go to run these down with the impact if I choose. With all the lug nuts started by hand, now I've got a choice in terms of how I get these set in place or run down. One of the things we can do is take our socket, we can do this by hand, run them down. I could also take a ratchet, put a ratchet on here, and do that by hand as well. Realistically, in the shop environment, I'm looking for efficiency, and so my pneumatic tool can help create that efficiency. The thing I've got to pay attention to is that this tool has a lot of range. The trigger that is here is not just an on-off switch, and that I can modulate it. That is something that takes a little bit of experience, and so I've got to use my ears and really pay attention to how tight am I making this, because I don't want to over tighten it in this step. So I'm going to put my tool on, get it ready to go. I want to make sure that I'm going in the proper direction. I got to switch this position so that now I'm tightening. I'm going to put my socket on, make sure that the wheel is going on straight, make sure that it's flat against the hub surface. Notice the sound that's coming out of this is very low pitched and it's very slow. I'm using my finger to just put a small amount of pressure on the trigger so that I get only a slow output. As long as I can do that, I won't over torque these wheels and I won't create other problems. With all these lug nuts ran down, the wheel is now tight against the hub surface. I can now lower the car to the ground, and that's going to allow me to better stop this from rotating as I go to do my final torque. I want to be mindful and careful about using other methods to keep this from moving. If I had a partner and maybe the vehicle wasn't done yet, couldn't go to the floor, they could hold onto the brake pedal for me, and then I could torque this. Some technicians might use a pry bar or a piece of wood through the wheel spokes to hold against a brake caliper or suspension component. I want to be cautious about this. It's a pretty awkward process where things could slip. I could hurt myself, I could hurt the vehicle. So we're going to lower it to the ground, use the contact on the floor to keep this from rotating. Because I just want to torque the wheels, I'm going to allow it just to touch and compress the suspension a little bit. For final torque, I've got some options about how to accomplish that. Generally, a torque wrench is a good choice. That's going to allow us to achieve a very specific level of torque on the fastener and have them all be equal. And that's really what we're after. And so this torque wrench is one of the styles that we could use. This one is adjustable with this flap and this thumb wheel. And so we'll go through setting up that one. Another style that I could have is this here, where I twist to make a selection. And then the other option that I'll see in some shops are these things called torque sticks. And so a torque stick is a piece of metal that goes on my pneumatic gun, and they're designed to be at different levels of torque. Some of them are even built with sockets or specific sizes. This one is a 19 millimeter rated for 100 foot-pounds. Or I can buy them like this, where I apply my own socket, half-inch drive, and then this is rated for 100 foot-pounds as well. These can be a great time saver, but it is something that we've got to pay attention to. They're utilizing an air impact gun with shop air, a numerous amount of variables that could impact the final outcome of the torque. And so if I'm going to use a torque stick like this, they can save me some time, but I do need to be diligent and perhaps use a standard torque wrench like this every so often, maybe every vehicle, to ensure that it's still doing what I think it should be. The premise of how this operates is that the metal on the shaft in the center here is actually designed to twist and absorb the impact once we get past 100 foot-pounds. And so there is some metal fatigue that can happen over time, and so I've got to keep a close inspection on this tool and again audit the final torque output every so often. For our purpose, we're going to use one of these two torque wrenches. And so this is one style that I've got. This one is adjustable by twisting the base. I look for these numbers that are graduated on here. Here's my 0. And so I twist this and I line up my numbers based on the torque that I want. And so say that we wanted 100 foot-pounds, I'm going to run this up. I'm going to look for the baseline where it says 100 right there to line up with that 0. Once I do that, I can lock the collar here, it won't twist anymore, and now I can use this to set a fastener to 100 foot-pounds. The other style of torque wrench we're going to look at is the SnapOn one, which is again a breakover style torque wrench. And this one's setup is a little bit different, maybe a little bit more user-friendly. I release a locking tab here, and then I twist this in order to engage the torque that I want. So if we wanted 100 foot-pounds, I could run that up to 100. It shows me 100 on this dial right here. I lock that, and now it's ready to be used. Before I set that torque wrench, I'm going to have to come to service information. Here we're on Pro Demand. We've looked up the 07 Eclipse, went under the wheel and tire section, and we found wheel nut. And here it shows me I should tighten this to 73 foot-pounds plus or minus 7. So I could be at 73 or as high as 80 foot-pounds and be within the specification. So we're back here. I've got my torque wrench set. I'm set just under 80 foot-pounds. I've selected a deep socket so that I keep my tool and my hands away from the face of the wheel. And I'm going to pick a lug nut to start with. I'm going to push, keep support here to make sure that the socket doesn't slip off. Push with my other hand, and typically it's best that I push down so that my weight can help me achieve this torque rather than pull up where I'm putting that stress on my knees. When I hit the torque, I should hear a click like that, and now I move on. This is where I need to go in a star pattern, so I'm coming across the wheel to this one. Hear that click. I'm going to go up and across, down, and then over here for my last one. You'll notice that pretty much all the lug nuts took the same rotation to achieve the proper torque, and that's one of the upsides of using an impact and really getting acquainted with how to run it at partial speeds and partial outputs. You end up saving time in the long run. I've hit all 5. I'm going to go back through and check one more time. So now that I've checked all of these essentially twice, I've got good faith that this tire and wheel assembly is on tight, and it's not going to be a safety risk. That's our overview of taking a wheel and tire assembly off and putting it back on. Keep in mind that there's some key things we want to remember. So picking the right tool. We want to make sure that we've got a socket that fits well. We want to check it by hand. Using the proper tool to loosen those as well. Looking at the hub surface once things are apart. We want to make sure that we're not going to incur runout as we put the wheel and tire assembly back on. Lastly, when we put that back on, wheel torque. We want to make sure that we use the proper torque recommended by the manufacturer with a tool and method that we trust and that we know can be repeatable. If we follow all these things, we know that we'll have a wheel and tire assembly on that is safe with no risk of it coming back off.